All right, in the second part of this lesson, we're going to look at 30, 60, 90 right triangles. And that relationship is quite different because the two legs are not the same measurement. So in these problems, you have to set up two proportions in order to find the two sides that are missing. Unlike Pythagorean theorem, what we've seen so far is that you don't need Pythagorean theorem to find a missing side if you only have one side of the triangle. Although with 45, 45, 90 right triangles, I could do it with the Pythagorean theorem. I didn't because the ratio relationship's a lot quicker. But in this I can't, because that would be like x squared plus y squared equals 8 squared. Where, let me go back a second here and talk about this one. See, this is 60 squared on number 3 plus 60 squared equals y squared. I could have used Pythagorean theorem for that. But here I can't because I just don't have enough information. And these special ones are so much better done with a ratio. So let's talk about the ratio for 30, 60, 90. It's 1 square root of 3, 2 relationship, in which if you have the short leg, you can multiply it by the square root of 3 to get the long one, or you can take the short leg times the hypotenuse, times 2 to get the hypotenuse. So in this one, I have the hypotenuse. And I'm wanting to figure out the angle across from 30 tells us that that short leg is x because it looks shorter than y. But if you're not sure, because maybe they're close to the same relationship, then take the one across from 30 and it's their short leg. Now in this case, I have to set up two different relationships. I have to set up 1 over x as 2 to 8, and I have to set the square root of 3 over y as in 2 to 8. And again, if you want to do any reducing, you can do that, like 2 over 8 reduces, or you can just let that come out when you're solving it. So cross multiply would be 2 times x, 1 times 8. And it's clear and obvious here that it's 4 because 2 goes in 8 4 times. So if this one's 4, it makes sense because you double it to get the hypotenuse. So I could half it to come backwards. When I cross multiply this other one, 2 times y, and square root of 3 times 8 is just 8 square roots of 3. You can't multiply those together because one's in a radical and one's not. But you can divide by 2. Now again, remember, it's the outside numbers can be reduced, and that's 4 square roots of 3. Which also makes sense because I said that if you had the short leg, you could just multiply it by the square root of 3 and it'd give you the long leg. But of course, they're not all quite that simple because that ratio relationship only works if you got a really nice short leg. To be able to see that relationship, it's just timesing. So let's look at number 5. So in this problem, we have the one across from the 60-degree angle, so that's the long leg. And then we have the 30-degree angle has D across from it, and F is the hypotenuse. So that's my triangle. For my ratio relationship, I have 1 square root of 3, 2. So first I would take the 2 over here on the left side and say 1 over D as the square root of 3 over 5 and cross multiply. The square root of 3 times D equals 5 times 1. Divide by the square root of 3. Again, this is one of those relationships where we have to rationalize. So I don't like square roots on the bottom, so I have to use that square root to get rid of it by putting the square root of 3 on top and bottom. That keeps your relationship of your fraction balanced. And that makes it 5 square roots of 3 over 9. But we know the square root of 9. It's 3. Now, I always look at those numbers on the outside. 5 and 3 are both primes, so they don't need reducing. But I should always check that. With the other two fractions, you always have to use the one that has both numbers in it, which was the square root of 3 over 5. But I use it with the other one that has the letter in it. So I cross multiply and get the square root of 3f. 2 times 5 is 10. And divide by the square root of 3. And again, if I multiply by the square root of 3 over the square root of 3, I get 10 square roots of 3 over 3 because we just found out a minute ago that that turns into 9 and becomes 3. So why do I need to redo that denominator work again? And 10 and 3 don't reduce, so I'll leave it like that. So here we have a few more examples, so maybe we'll choose one more to do together. Let's see. I think we'll do number 13 together. It looks like it's a little different. So again, our ratio relationship for 30, 60, 90 right triangles is 1 square root of 3, 2. But they gave me the hypotenuse is 2 square roots of 3. And I know the shortest leg on this picture is x, and the longer legs across from 60 is y. So that's my information off my triangle. I have to take 2 of these at a time. So I can take 1 over x. Now I can't put it with the second column because it has a letter in it. I have to put it with the last column, 2 over the 2 square roots of 3. And then I can take the square root of 3 over y and put it with 2 over 2 square roots of 3. So again, you have some choices on what you can do. And a lot of times if you see something cancels, it'll just make the math go so much faster to cancel that now. So x times 1 is x, and 1 times the square root of 3 is the square root of 3. Same thing in this one. I can cancel these 2's out, and when I cross multiply, 1 times y is y, and the square root of 3 times the square root of 3 is the square root of 9, which comes out 3. So stop the video and see if you can try a few of these on your own. So in our next question, which side do we have given? Well, let's write our ratio down and see if we can figure that out. So 1 square root of 3, 2 is our relationship. This side is across from the 30-degree angle, so that's our short side. It looks much shorter than y for our long leg, and x is our hypotenuse because it's across from the right angle. So this time we're going to use 1 over 12 with our other two fractions. So 1 over 12 as the square root of 3 over y. If you cross multiply, you get y equals 12 square roots of 3. And that's all you need to do with that. If you have 1 over 12 and you put it with 2 over x and cross multiply, you get x equals 24. On our next one, they gave us the one across from 60. That means it's the long leg. And so as I fill in my table, again, I want to say the ratio relationship of a 30, 60, 90 is 1 square root of 3, 2. But on my triangle, I've got the long leg, 2 square roots of 3, because it's across from 60. The one across from 30 is your short leg, and the one across from the right angle is your hypotenuse. So this time I am going to use 1 over y with the square root of 3 over 2 square roots of 3, and then I'm going to use 2 over x with the square root of 3 over 2 square roots of 3. So I used that middle one with the 2 on the outside. So first of all, I noticed that these two radicals will drop. So 1 times y is y and 2 times 1 is 2. Same thing here. I'm going to drop my radicals. So 1 times x is x and 2 times 2 is 4. So that makes the question a whole lot easier to work if you reduce those fractions before you start cross multiplying. All right, and this one, the one across from the 30 is your short leg. So if I write my ratio relationship, 1 square root of 2, 3. Whoop, wrong one. We had a little dyslexic this morning. Square root of 3, 2. Then my relationship that is that 2 square roots of 3 is the short leg because it's across from 30. And y is across from the other angle, 60, even though they didn't mark the 60 because it's the other leg. And x is your hypotenuse. So I'm going to use 1 over 2 square roots of 3 with the square root of 3 over y. We're going to cross multiply and get y equals 2 square roots of 9, because 3 times 3 inside the radical. 2 times 3, because we know the square root of 9, comes out 6. Now let's take 1 over 2 square roots of 3 and set it equal to 2 over x. Again, 1 times x is x. 2 times 2 is 4 on the outside. See, that's the one thing that's interesting. In this first one, we had 2 radicals. We could multiply them together. But in this one, we're looking at we have 2 whole numbers that we can multiply together that are both outside. Now on this, I think this is our last page. Yes, it is. On our last page, we have a mixture. Each of these pictures, and I may not even have enough tables to do it all, but each of these pictures that you have here is going to need you to set up something with 30, 60, 90 right triangles. We'll go through this couple of these together, and then you can finish the rest yourself. So in this first one, we've got a 45, 45, 90 right triangle mixed with a 30, 60, 90. So let's start off with the 45, 45, 90, because it's the only one we have a number on. So the ratio relationship of a 45, 45, 90 is 1, 1 square root of 2, where the 2 legs are the same number. Your triangle here says you have A and C for your 2 legs and 7 square roots of 2. So if I take this, just this last part here, and find C, I'll have A. So 1 over the C is the square root of 2 over 7 square roots of 2. We know these square root of 2's will cancel out. And when I cross multiply, I get C equals 7. So that means A is 7. So we go up here on our picture and we label that. Now why we need that is because you have to have at least one side on your triangle given if you're going to find anything else about it. So that A is our one side across from the 30, or the short angle on this triangle on the right side. So we're going to write our relationship. Our ratio is 1 square root of 3, 2. And our triangle, so far all we have is 7. We know that D is the other leg and B is our hypotenuse. So in this one, I would take and work with 2 ratios. I would work with this 1 over 7 with the 2 over B. 1 over 7 equals 2 over B, because cross multiplied makes that 14. But to do the other one, I have to have 1 over 7 is the square root of 3 over D. And so when I cross multiply that one, 7 times the square root of 3 is 7 square roots of 3. Now we probably should look at one of these down here at the bottom because they look different, and the ones at the top do look kind of similar. And again, I may not have put every table you need. For example, on number 25, you need another table like leg, hypotenuse. And on number 26, you need 2 different sets of short leg, long leg, hypotenuse. I just didn't put as many because I was trying to leave myself some space to work them. So let's look at one of these down here at the bottom. And I'll just choose the first one here at 27. So if I drop a perpendicular here to make a right angle and cut this up into 2 different shapes, this would be 2 square roots of 3 long. And that's important because that can help me maybe define some information on this picture. So let's fill in our chart. Our ratio is 1 square root of 3, 2, because it's a 60-degree angle across from that 2 square roots of 2 long leg. I'm looking for the hypotenuse A, and so in order to do that, I don't really need the short leg. I don't need this little piece from here to here, although I might find it to be able to find B, but I don't need it to find A. So I set up my ratio, square root of 3 over 2 square roots of 3 equals 2 over A. And these 2 cancel out. So A will be equal to 2 times 2 is 4. Now that I know that A is 4, then I can go back and I can find my other measurement. because now I can say 1 over what equals 2 over 4. And it looks like they just doubled the top. So what can you double on the bottom? Would have to be 2. So now I know this little piece is 2 right here. So that tells me if all the way across is 6 and this part of it's 2, then this part down here has to be 4. Because you can subtract off that piece to see how much shorter it gets. So the ratio relationships don't just help you to find pieces of the triangle, but it helps you to subtract and find other pieces. So you can stop the video now, try a few yourself, and hopefully when you come to class tomorrow you'll have a good understanding of 45, 45, 90 and 30, 60, 90. I may work a couple more of these, but I'm running close on time for making a video. So I think I'm just going to stop at that point. And if I don't finish this video, you can check them with your teacher. So I did have quite a bit of time. No one's waiting for tutoring, so I'll try to finish this video. So let's look at number 25. So I know that the hypotenuse is 4 square roots of 3. And I have my ratio relationship written as 1 square root of 3, 2. And they want you to find the short leg is C and the longer leg is A. So in this case, the square root of 3 over A equals 4 square roots, well, got to put the 2 on top. 2 over the 4 square roots of 3. So if I cross multiply, 2a equals 4 times the square root of 9. Now 4 times the square root of 9 I can come back to. But divide by 2 gives you 2 square roots of 9. And 9 square roots to make 3, so that comes out 6. So a is 6. Now why that's important, because if a is 6, b is 6. So that's really important to get that number because it gives you 2 of them. Then I can go back and I can set up a relationship for the other one. 1 over C equals 2 over 4 square roots of 3. And 2C equals 4 square roots of 3 divided by 2 comes out 2 square roots of 3. Now, to finish this relationship up, it is a lot easier to get the hypotenuse of a 45, 45, 90, because all you do is take the leg times the square root of 2. You don't need a whole chart to do that. All right, let's look at this next one. They gave us 10, a hypotenuse, on a 30, 60, 90 right triangle, so I'm writing in the ratio for that. And I'm going to work on this right side first. So I need to know what D is, which is the short leg, and B is, which is the long leg of this triangle. Again, 1 over D is to 2 to 10, if I cross multiply and divide, gives me 5. So now I know this one's 5. And if I take and work, I'm running out of room here, so let me erase a little bit here. The square root of 3 over b, as in 2 over 10, 2b equals 10 square roots of 3 divided by 2 gives me 5 square roots of 3, which I could have gotten without doing what I just did, because the short leg you always multiply by the square root of 3 to get the long leg. Now I'm going to erase my table, because now I've got to start a whole different table for short leg, long leg, hypotenuse of a totally different picture. We got to do the left side now. So the short leg has been given 5 square roots of 3. That's because it's across from 30. The long leg is C and A is the hypotenuse for my triangle. So if I use some shortcuts, you're just supposed to double to find the hypotenuse. Let's see why. When you cross multiply, you get to double. So there's what A is. And then if I just look at this right here, I can cross multiply and get C equals 5 square roots of 9, which is 3, And 3 times 5 is 15. Well, that was not 10. 5 squared is 3. It's 10 squared is 3. Excuse me, I got the hiccups. Alright, let's look at the last two. So if you bring down this line right here, then you can figure out how long the sides of this 45, 45, 90 right triangle is without this table. Because the relationship's 1, 1 square root of 2. So if this is 3 square roots of 2, these two have to be 3 because all I did was add the square root of 2 of it when I got to the end of the line on the first one, so that seems reasonable for the second one. So these are both 3. If that's 3, then this whole length here, from here to here, would have to be 7, because 3 plus this piece here for 4 makes 7. And then this over here would have to be 3. Now in this one, if I do the same thing, if I drop this line and this is 6, then this is 6. And if those are both 6, then the length all the way across the bottom has to be 14. And again, this relationship is 1, 1 square root of 2. So 6, 6, put a square root on it. That's all it does is when you cross multiply. So that's how simple that is. So now it's time for your homework.